Good morning, everyone. I'm Nithiyanandam. I'm working as an assistant professor in the Department of Computer Science and Engineering in Bharat Institute of Higher Education and Research. Today, I'm going to discuss about cryptography basics. In cryptography basics, cryptography is a study of secure communication technique that allow only the sender and intended recipient of a message to view its content. So that is the definition of cryptography. In prefix of cryptography, crypt stands for hidden and the suffix graphy stands for writing. Next, we are going to discuss about the basic principles of cryptography. In cryptography is a science of secret or hidden writing. It has four principles. First one, encryption. Second one, authentication. Third one, integrity. And fourth one, non-repudiation. We'll see one by one. First one, encryption. Encryption is to convert the data in same unreadable format. So we have a data, we need to send the same confidential information to particular person or particular organization. We need to protect the data. So in between sender and the receiver, anything may happen. So we need to protect. The encryption is to convert the data in some unreadable format. This helps to protect the privacy while sending the data from sender to receiver. On the receiver side, the data can be decrypted and can be brought back to its original form. The concept of encryption and decryption requires some extra information for encrypting and decrypting the data called key. So we need to protect our data while transferring, while sharing, while communicating. Any person, any attacker, any malware can read your data. So we need to convert your data in unreadable format. So for that, we need to do encryption in the sender side. We need to do decryption in the receiver side. So for that, we need a code, particular code to encrypt the data and decrypt the data. That code is called key. There may be a cases when same key can be used for both encryption and decryption, while in certain cases, encryption and decryption may require different keys in some cases. Second one, authentication. So this is another important principles of cryptography. In a layman's term, authentication ensures that the message was originated from the originator client in the message. So that is a concept of authentication. So this is one of the important principles of cryptography, because I'm a owner of a particular message. I have sent a particular message to organization or particular person. So I should claim that message, that document is my message. Okay, that is my message. So that will be ensured. Because of cryptography. Because of cryptography, we can ensure so your originality, okay, your ownership. So that is the concept of authentication. Second one, integrity. Integrity means the cryptography should ensure the message that are received by the receiver are not altered anywhere. So that is the concept of integrity. Integrity ensures in cryptography your received message never altered anywhere in between sender and receiver on the communication path. This can be achieved by using the concept of cryptographic hash. Okay, we'll see in the next slides. We'll discuss about hash. Fourth one, non-repudiation. And non-repudiation is the assurance that someone cannot deny the validity of something. For example, I have sent a document to organization. So purely it is digital communications. They can't deny my ownership. Okay, they can't deny my ownership, because nowadays all the communications, all the informations are digitalized. All are digitalized. So no one can deny our ownership of a document. Non-repudiation is a legal concept that is widely used in information security and refers to a service which provides proof of origin of data and the integrity of the data. Non-repetition makes it very difficult to deny who or where a message came from, as well as the authenticity and integrity of the message. Digital signature can offer non-repetition when it comes to online transactions. In this context, non-repetition refers to the ability to ensure that a party of contract or a communication must accept the authenticity of their signature on document or the sending of a message. So digital signature is one of the example for non-repetition. No one can deny your ownership. No one can deny your authenticity. So that is a concept of repetition. So we have 4 basic principles in cryptography. First one, integrity. Second one, authentication. Third one, integrity. Fourth one, non-repetitions. So these are all the 4 basic principles in cryptography technique. So next we are going to discuss about types of cryptography. So there are 3 types of cryptography technique. First one, secret key cryptography. Second one, public key cryptography. Third one, hash function. Okay, based on the keys where we are using, based on the different types of keys we are using, based on the techniques we are using, okay, we have 3 types of techniques. Okay, we have 3 types of techniques we are using. So we'll see one by one. Okay, first one, secret key cryptography or symmetric key cryptography. Okay, we can say secret key cryptography, or in the case symmetric key cryptography. Okay, I will tell you why we are calling secret key cryptography as a symmetric key cryptography. This type of cryptography technique uses just a single key. Okay, just a single key. Okay, both in the sender side as well as in the receiver side. Okay, we have used a single key for encryption, single key for decryption. First point, this type of cryptography technique uses just a single key. Okay, just a single key. Second point, the sender applies the key to encrypt a message while the receiver applies the same key to decrypt the message. So that is the concept of symmetric cryptography. That's why we called this cryptography, named it as symmetric cryptography. Okay, the sender applies a key to encrypt a message while the receiver applies the same key. Whatever key you have used in the sender side for encryption, that same key we have used in the receiver side to decrypt the same message. Okay, so that's why the name came symmetric cryptography. Okay, symmetric cryptography. Third point, since only single key is used, so we say so that this is a symmetric cryptography or symmetric encryption or symmetric decryption. Okay, the biggest problem with this technique is distribution of key. Okay, distribution, whatever key we have used for encryption, we have to use the same key for decryption in the receiver side. So we need to distribute the key from sender side to receiver side. So we need to distribute. That is the big problem in this mechanism. We need to distribute. We need to share the secret key from sender to receiver. Okay, sender to receiver. While sharing the key, while publishing the key, anything may happen. Any attacker, any malware can read, can damage, can delete whatever plan they have. They can implement. Okay, while transferring key, while sharing the key. Okay, you can see this diagram. You can see this diagram. Okay, this is a sender side. This one is a receiver side. Okay, this is actually a plain text. With the help of the secret key, shared key, we can encrypt the plain text. That is cipher text. So once the key is encrypted, once the plain text is encrypted, okay, that document is named it as cipher text. Okay, cipher text. Okay, So then we can send a document, send the encrypted document to receiver side with the help of same key. Okay, with the help of same key, the sender has to decrypt the message. Sender has to decrypt the message. Okay, in the sender side, we are using the same key for encryption. In the receiver side, we are using the same key for decryption. So that's why the name called symmetric cryptography. Symmetric cryptography. And one more thing, in this, we have used for encryption, decryption, that is purely secret. Okay, that is purely secret. We are not, okay, we are distributing the key, but sender and receiver both should know the key. Okay, no one know the key because it is secret key cryptography. Okay, sender distribute the key to receiver. In this scenario, sender and receiver know the key. No one know the key because we are not publishing, just we are distributing the key from sender to receiver. So next cryptographic technique is public key cryptography. Other name is asymmetric cryptography. Okay, public key cryptography or asymmetric cryptography. So I will tell you why the name came asymmetric or public key cryptography. In public key cryptography involves a pair of keys. Okay, in secret key cryptography, we have used a single key, but in public key cryptography, we are using pair of keys. Okay, known as one is public key, another one is private key. Okay, another one is private key. So in this scenario, in this technique, we have used a pair of keys known as public key, another one is private key. Okay, private key. Second point, each public key is published. Okay, in this scenario, we have used two keys. Okay, the first key, public key, is published. Okay, whoever involving in the network, not only sender and receiver, not only sender and receiver, whoever involving, whoever is enabled in the network, all can able to read this public key. Okay, read this public key, not only sender and receiver, whoever involving, whoever active in the network, anyone can see, anyone can read, anyone can use this public key. Okay, anyone can use this public key. Each public key is published, that means shared, and the corresponding private key is kept secret. That is important. Okay, in this scenario, we have used two keys. One is public key, another one is private key. Public key is common to all, but private key is kept secret. Okay, so each and every node has its own private key that is purely secret. So each and everyone have a public key that is common to all, whoever involving, whoever active in the network, Data that is encrypted with the public key. Okay, data that is encrypted with the public key, that will be communicated through communication channel. Okay, that can be decrypted only with the corresponding private key. Okay, only with the corresponding private key. In this scenario, in this technique, encryption made with the help of public key, decryption made with the help of private key or secret key. So that's why the name came public key cryptography or asymmetric cryptography. Okay, encryption made with the help of public key, decryption made with the help of private key or secret key. So public key is published, shared with anyone, all. Okay, for example, 1,000 nodes involving in the network. So all the 1,000 nodes knows the public key. Okay, whoever involving in the network, all can able to read that particular public key. But secret key or private key, each and every node has its own secret key, has its own private key, that is not shareable, that is purely secret. Okay, but that is purely secret. Here encryption made with the help of public key, that will be shared to network devices through communication channel, that will be decrypted with the help of secret key. that will be decrypted with the help of secret key. So this is the concept of public key cryptography or asymmetric cryptography. Okay, you can see the graphical representation of public key cryptography. So this is a sender, this is a receiver. Okay, sender has to send a plain text with the help of public key. With the help of public key, this plain text will be encrypted. This plain text will be encrypted. That cipher text is sending via communication channel. The recipient decrypt that cipher text with the help of private key, not public key. Sender knows the public key, receiver knows the public key, but sender encrypt the message with the help of public key, receiver decrypt the cipher text with the help of private key. Okay, private key. So that's why we named here asymmetric cryptography. Asymmetric cryptography means, okay, different types of keys were used for encryption and decryption. Here public key is used for encryption, private key is used for decryption. So that's why we named it as asymmetric cryptography. If we have used same key for encryption, same key for decryption, okay, we can name it as symmetric cryptography. But here we have used two keys for encryption. Okay, encryption, public key for encryption, private key for decryption. So that's why we called it as asymmetric cryptography. Third one is hash function. A hash function is a unique identifier for any given piece of content. Hash function is a unique identifier for any given piece of content. Okay, you know secret key cryptography, you know public key cryptography. There is a concept of encryption, there is a concept of decryption, but here hash function is totally different. Okay, hash function is totally different. Hash function is a unique identifier. Okay, is a unique identifier for any given piece of content. For any piece of content. It's also a process that takes plain text data of any size, whatever input you have given, whatever size of input you have given for communication. Okay, for communication, and it converts it into unique cipher text of a specific length, whatever size of you have given, whatever size of input you have given. But hash function converts your input data into fixed particular size output. It converts into unique cipher text of specific length. Okay, specific length. For example, you have given 5 kilobit data, it will convert into specific length of output. Okay, you have given 10 kilobit of data, but it will give the same size of output data. Okay, you have given 15 kilobit of data, but it will give the same size of output data. Okay, whatever size of input you have given, the hash function convert into unique cipher text of a specific length. Okay, unique cipher text of a specific length. That is the beauty of hash function. That is the beauty of hash function. Third point, hashing functions are an essential part of cyber security. Hashing functions nowadays, hashing functions are an essential part of cyber security, and some cryptocurrency protocols. Okay, for example, Bitcoin. Okay, Bitcoin. So hashing function plays a vital role nowadays. Okay, it is an essential part of cyber security as well as cryptocurrency protocol. Okay, example, Bitcoin. We can put data into hashing algorithm. Okay, you know already. So whatever communication you need to do before you need to encrypt the data. Okay, you need to convert that readable format into unreadable format. Okay, for that you need to feed. Okay, you need to feed a data. So we can put data into hashing algorithm, and get a unique string. Okay, you can get a unique string. So we need to feed a information. We need to feed a input data to where. Okay, if you are using secret key algorithm, or if you are using public key algorithm, public key cryptography or hashing, but we need to feed input data. Okay, we can put any size of data to hashing algorithm and get a unique string. Okay, whatever size of data you have given, whatever size, small, okay, small in size or large in size, okay, whatever size of data you have given to hashing algorithm, you can get a unique string only. You can get a unique string only. Hashing is a mathematical operation. Hashing is a mathematical operation that is easy to perform but extremely difficult to reverse. Okay, in secret key cryptography, we are doing encryption and decryption. So decryption is a reverse of encryption. It is pure. It is a completely easy task. Okay, in public key cryptography, we are encrypting in the sender side, decrypting in the receiver side. So that is the reverse of encryption. So it is completely easy task. But in hashing, reversing, okay, reversing is a difficult task. Okay, difficult task. So hashing is a mathematical operation that is easy to perform but difficult to reverse. The difference between hashing and encryption is that encryption can be reversed or decrypted using a specific key. With the help of specific key, we can decrypt in single key, secret key cryptography or public key cryptography. But here we are not using any kind of keys. Okay, here we are using hashing function. Okay, any kind of data, any size of data, we can give it to algorithm. Algorithm process it and it can give a same unique size of ciphertext. Okay, unique and the same size of ciphertext. That is the beauty of hash function. But here reverse is difficult to do. Here in hash function, okay, reverse operation is very difficult to do. The most widely used hashing functions are MD5, SHA1 and SHA256. So these are all the hashing algorithms, okay, in mostly used in cryptography functions, cryptography communication. Okay, MD5, SHA1 and SHA256. So these are all the algorithms most widely used hashing functions nowadays. Okay, you can see the example. Okay, this is an example hashing function hash code for this is an example of SHA1 data and hashes. SHA1, okay, I already told you SHA1 is a mostly used hash functions nowadays. Okay, for example, first example, hello. Okay, first example, hello, how many characters are here? 1, 2, 3, 4, 5. Only 5 characters are here. What about the hash value? What about the what about the ciphertext value? You can check. What about the ciphertext value? So it has some it has some length. Okay, it has some size. Okay, this is a output of hash function. This is output of hash function. Okay, from SHA1. Okay, what about the second example? Okay, second example, the quick brown for jumps over the lazy dog. Okay, lazy dog. Okay, this is a input data. Okay, given to hash function or hash algorithm. Okay, first example only hello. Second example, it is a praise. Okay, it is a praise. What about the output ciphertext? It is also same size. Okay, it is also same size but unique. Okay, but unique. What about the third one? It is purely number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But okay, this is the input of hash function SHA1, but it gives the same sized unique ciphertext value. Okay, ciphertext value. For hello, we can get the same size unique ciphertext. For the pace, we can get same size unique ciphertext. For numerical value, we can get same sized unique ciphertext. Okay, this is a beauty of hash function. Whatever size of data we have given to hash algorithm, we can get same sized unique ciphertext value. Okay, unique ciphertext value. Hash takes a plain text data of any size. Hash takes plain text data of any size. Okay, the data may be a single character, or a word, or a phrase, or a number, any size. Okay, and convert it into a unique ciphertext of specific length. Okay, unique ciphertext of a specific length. That is a beauty of hash function. That is a beauty of hash function. Who uses hashing? Who uses hashing? Okay, we all are using hash function daily, but we don't know. Okay, we all are. Okay, whoever all are in online. Okay, all are. If it is a if he is a student, if he is a businessman, he's a IT people, whoever, but we don't know. All are using hash functions in our daily we are using hash functions, but we don't know. Okay, so first point, the average user encounters hashing daily in the context of passwords. Okay, daily in the context of passwords. The average users encounters hashing daily in the context of password, but we don't know. Okay, for example, when you create an email address and password, your email provider likely does not save your password. Okay, for example, my email ID N.N.Nithiyanandam or nithyandham.csc@bharatuniv.ac.in. That's my mail ID. Okay, I have a password. While creating email ID, while joining here, they have given email ID and email ID. Okay, we can reset the password, but email provider never store your password. Whatever password you have, they are not storing the same password in the store database. Never. Okay, rather the provider runs that password through a hashing algorithm. Okay, they have given your password as an input to hashing algorithm, and save the hash of your password, Your password has been given to hashing algorithm. Okay, hashing algorithm process your password and give the output. Okay, and give the output. The output contain, okay, it is purely ciphertext. No one can read. Okay, if it is read, they can reverse. Okay, that is the beauty of hashing function. Okay, in single key cryptography or secret key cryptography or in public key cryptography, reversing is possible. Okay, reversing is possible. Decrypting is possible. If they know the key, they can easily decrypt. Okay, for attempting more and more number of times. Okay, they can decrypt the data one day or any moment of time. They can decrypt the data, but here they never reverse. They never decrypt your data. Okay, so in email provider, they have given your password as an input to hashing algorithm. Hashing algorithm process it and give the ciphertext output. Okay, give the ciphertext output. That ciphertext output is stored in the database. Okay, the ciphertext output stored in the database. Rather, the provider runs the password through hashing algorithm. Okay, each and every time, whenever you are given a password, okay, it has to convert into hash code, hash value. Then matching will be processed. Okay, third point, every time you attempt to sign in into your email, the email provider hashes the password. Okay, whenever you entered into email, whenever you have given your password, that will be hashed. Okay, that will be hashed. Your password will be hashed. Your password will be converted to hash value. Okay, your password value, your whatever password you have given, that password will be converted to hash value. Okay, hash value. Email provider hashes the password, you enter and compare this hash to the hash it has saved. Already they have a ciphertext, your password in their database. Okay, whenever you have given a password, it will be converted to hash value. That hash value, okay, should be matched. Okay, should be matched with their database ciphertext. Okay, if it is matched, you can enter into your login. Okay, else you can't enter into your login. Okay, that's why I told hash function reverse is very difficult. Okay, than single key cryptography or public key cryptography. So nowadays hash functions plays a vital role in cyber security and cyber forensics. Fourth point, only when the two hashes match, okay, are you authorized to access your email. Okay, both are matched, you can enter. Else you can't enter into, you can't access your account. You can't access your account. So that is the beauty of hash functions. That is the beauty of hash functions. Next one, hashing helps us to securely store passwords in a database. Okay, securely store passwords in the database. Hashing, that is one of the example of hash function. Hash functions securely store your password in a database. Second one, hash function ensure data integrity. That is very important. Okay, that is very important. We already seen in basic principles of cryptography. Data integrity. Hash functions ensures your data integrity. Okay, once the receiver receives the data, he has to ensure the data never altered in between sender to receiver. While communicating, while transferring, while sharing data, the receiver has to ensure the data is original data. Okay, it never altered in between sender and receiver. Who ensure? Okay, with the help of hash function. So hash function ensures data integrity in a lot of different applications by indicating when data has been altered. Okay, indicating when data has been altered or your data is safe. Okay, third example. Okay, third use, make secure authentication possible. Make secure authentication possible. Okay, what about authentication? Okay, nithyandham.cac@bharatuniv.ac.in. It is my account, email account. Okay, I'm an authenticated person. I have a mail ID. I have a password. Okay, so I have to ensure no one can access. Okay, I have to ensure my privacy. I have to ensure my security. All the contents, whatever content, whatever mail I have, that is purely secured. I have to ensure with the help of hash function. Okay, hash function makes secure authentication possible because my passwords are converted to hash value. So no one can read. If they can read, no issue. Okay, no issue. They can't reverse. They can't decrypt. Okay, they can't decrypt. So no issue. If they know the ciphertext or hash value, they can't reverse. They can't convert into my original password. So that is the beauty of hash functions. Okay, that is the beauty of hash function. Hash function makes secure authentication possible. Fourth use, organize content and files in a way that increases efficiency. That is the most important use of hash functions. Okay, hash functions. So hash function organize content and files in a way that increases efficiency. Okay, it reduces the time complexity. It reduces the time to fetch the data, to store the data. It is very simple. Okay, in forthcoming days, you can realize the impact of hash functions. It is very easy. It is very it reduces the time consumption. You already studied in data structure. A number of ways to store a data, a number of ways to fetch data, a number of ways to store data. Okay, store data. You already studied in data structure. A number of algorithms are there. To store, to fetch. Okay, for example, you have a mobile. Okay, you want to play a song, or you want to play a video. When you click a particular video, or when you click a particular song, immediately you can hear, immediately you can view. How it is possible? Okay, algorithm they are using. Okay, algorithms are they are using for storing, for fetching, for whatever okay actions you have made. Immediately you can get a reply. Okay, immediately, very in fraction of time, in a fraction of seconds, in a fraction of moment, you can get a reply from the computer devices. Okay, in electronic devices. How it is possible? With the help of algorithm. So hash function is one of the algorithms for storing easily, for storing quickly, for fetch the data quickly. So hash functions helps lot of areas in a computer sector, in digital world, in cryptography environment. So first, help securely store passwords in a database. That is very important. Second one, ensure data integrity. So hash functions ensure your data, your received data is your data never altered while transferring, while communicating. Third, help make secure authentication possible. Okay, secure authentication possible. Your password will be converted to hash value. Okay, no one can revert, no one can decrypt the hash value. It is impossible. Fourth help organize content and files in a way that increases efficiency. Okay, if you get quickly, if you fetch quickly, if you store quickly, okay, efficiency automatically will be increased. Okay, efficiency automatically will be increased. Okay, next one, difference between symmetric and asymmetric cryptography. Okay, difference between symmetric and asymmetric cryptography. You know already what is symmetric encryption or symmetric cryptography, what is asymmetric encryption or asymmetric cryptography. Okay, okay, while communicating, okay, before transferring data, we need to encrypt. Okay, we need to encrypt the data before sending information. So once the data transmitted to receiver received, after received the data, the receiver has to decrypt the data. So in the communication system, we need to do two things. One is encryption and decryption. So for encryption and decryption, we have to use a key. Okay, either secret key or public key. Okay, whatever key we have used. Okay, either we have used same key for encryption and decryption. Okay, either we have used a different key for encryption and decryption. If we have used same key for encryption and decryption, okay, it is called symmetric encryption or symmetric cryptography. Okay, if we have used two different keys for encryption decryption, okay, the name called asymmetric encryption or asymmetric cryptography. Okay, we'll see whatever differences are there between symmetric cryptography and asymmetric cryptography. First point, in symmetric cryptography uses a single key to encrypt and decrypt the data. Okay, you already know. Okay, you already know the concept. Okay, in this scenario, we have used a single key for encryption in the sender side, the same key used for decryption in the receiver side. In asymmetric encryption, it uses two separate keys for encryption and decryption. They are known as public key and private key. You already know. Second different, in symmetric encryption, it is more straightforward and conventional method of encryption. Okay, conventional method of encryption. Okay, it is more straightforward. There is no complexity for encryption. There is no complexity for decryption because we have used a single key for encryption and decryption. What about asymmetric cryptography? Here we have two. Okay, here we have used two keys. For encryption, we are using public key. For decryption, we are using secret key. Okay, here we have used two keys. Okay, public key is common to all, but the secret key or private key is different. Okay, very secret. Each and every node has its own secret key. So in asymmetric encryption, it was invented to mitigate the risk of symmetric encryption, and this is more complicated. Okay, symmetric is not a complicated one, it is a simple one, but in asymmetric cryptography, it is complicated one. Third point, third different. In symmetric encryption or symmetric cryptography, it is faster when compared to asymmetric encryption, because we have used a single key for encryption and decryption. So definitely it will be faster. What about asymmetric cryptography? We have used two keys, encryption, public key for encryption, private key for decryption. So definitely it will be slower compared with the symmetric cryptography. Okay, come to fourth one. Symmetric encryption or symmetric cryptography requires smaller key length. Okay, smaller key length, usually 128 bit to 256 bits of keys we have used in symmetric cryptography. But in asymmetric cryptography, we have used longer keys for encryption, longer key for decryption. Okay, longer key for decryption. Okay, next different is in symmetric cryptography, it provides confidentiality of the data security. It ensures the confidentiality, or it has ensured the data security. But in asymmetric cryptography, it provides confidentiality, authenticity, and non-repudiation. Okay, that is the difference between symmetric and asymmetric cryptography. Okay, next different, it is useful for encrypting a large amount of data. Okay, this symmetric cryptography, using symmetric cryptography, okay, we can encrypt a large amount of data. But in case of asymmetric cryptography, okay, we can encrypt a small amount of data. We can encrypt small amount of data. Okay, last different. Okay, that means standards. Whatever standards we have used for symmetric, whatever standards we have used for asymmetric. Okay, here RC4, AES, DES, 3DES, and quad. So these are all the algorithms, encryption algorithms used in symmetric encryption or symmetric cryptography. What about asymmetric cryptography? Okay, we have used RSA, very famous algorithm, RSA. Okay, then Diffie-Hellman, ECC, EA-Gamel, and DSA. So these are all the famous algorithms. These are all the mostly used algorithms in asymmetric cryptography or asymmetric encryption. Okay, thank you all. So we are in the end of the session. So in this session, we have discussed very basic concepts of cryptography. So what is cryptography? What is the concept of cryptography? What are the basic principles involving in cryptography? What are the terms used in cryptography? So what are the techniques we have used for encryption and decryption? What kind of cryptography techniques we have? Okay, single key cryptography, public key cryptography, hashing function, and then how hashing is important nowadays, how hashing works, how important nowadays hashing is. Okay, these things we have clearly studied in this session. Okay, if you have any doubts, please ask. I am ready to give a solution for your doubts. Thank you all.